Hi all. I will be talking about chapter 2 today. I will need 2 days to finish chapter 2. Um, Let me first look at the topics in the study guide that we need to cover in chapter 2. Okay. Chapter 2 is on data warehouse. Within a data warehouse, the things that are important are we need to know what is a data warehouse, then what are some of the characteristics of a data warehouse, then we need to know what is a data mart, what is an independent data mart, what is a dependent data mart, what is metadata, what is enterprise data warehouse, and what are operational data stores. Okay, and then we need to go over figure 2.1 in the book, which is basically the data warehousing process. This is very important that all of us understand the process through which the data warehousing takes place. Then we need to look at what are middleware tools, what is meant by data integration, what is an ETL process. ETL is extraction, transformation, and loading process. Okay, what are some of the benefits of the data warehouse, and then what is an Inman model and a Kimball model? What is we have talked about in chapter 1, OLAP on analytical processing and transaction processing. Okay, we have talked about it last time. We will talk about OLAP and OLTP more, and then we will talk about the differences between real-time data warehouse and traditional data warehouse. Okay, I would try to cover all this today, and the next day we would talk about designing a data warehouse, building a data warehouse, and within that we will we will talk about what is a primary key, what is a composite key, what is a foreign key, and what is dimensional modeling, and what is star schema. Okay, so I'm keeping the building of the data warehouse on the next day because this is more technical, and we have an assignment on that. Assignment 3 is on building a data warehouse, basically designing a data warehouse. Okay, so you need to understand how to design a data warehouse, otherwise your assignment 3 will not work. Okay, so I'm keeping it for next day. Today, as I was telling you, I will talk about the other concepts of data warehousing, and eventually designing of the data warehouse we will talk the following day. So these are the topics that I would be covering from chapter 2. Okay, so let me pull up the PowerPoint slides now and see what are the different topics that we would like to cover from there. Data warehouse is central to business intelligence. Okay, so it's very important. It's the foundation of business intelligence. So it's very important that all of us understand what is a data warehouse. Okay, now data warehouse, definition wise, it is, as I was telling you, it is the foundation of business intelligence. Data warehouse is like a database. Okay, it is a pool of data for decision making. Okay, so it's like a database, a huge, humongous database. It's a pool of data for decision making. Also, it is a repository of current and historical data. Okay, so what are the characteristics of a data warehouse? We will look at some of the characteristics of a data warehouse. A data warehouse is subject oriented. That means that a data warehouse is organized by detailed subjects such as sales, products, customers. Okay, it is integrated. Integrated means data from different sources are placed in a consistent format so that there is no naming conflicts, no discrepancies among units of measurement, etc. It's time variant. Time variant means historical data stored. It can detect trends, deviations, long-term relationships. Okay, you can have daily, weekly, or monthly views of data. It's non-volatile. That means users can't change or update the data. It is web-based, so it is accessible. Okay, it can be relational or multidimensional. That means it uses a relational or a multidimensional structure. Okay, it has the client server. It uses the client server architecture to provide easy access to end users. Okay, and it can be real time. That means it provides real time or active data access and analysis capabilities. Okay, real time means active data access. Okay, instant data access and analysis capabilities, and it also includes metadata. Metadata means data about data, or data about how the data are organized and how to effectively use them. So these are the characteristics of a data warehouse. So data from different sources are integrated and are placed in a consistent format. They are organized by detailed subject like sales, customers, products. Okay, the historical data can be stored and they can be used for detecting trends, long-term relationships, deviations. Okay, users cannot change or update the data. It's easily accessible, so it's web-based. It supports or uses a relational or a multidimensional structure. Then it has a client-server architecture. Data can be accessed real-time for analysis, and also it tells us about how data is organized, and so how we know how to effectively use them. Okay, then we will talk about 3 types of data warehouses. Okay, 3 types of data warehouses. Within that, the first type is called data mart. What is a data mart? Data mart is a subset of a data warehouse. A data warehouse is huge. It's for the whole organization. Okay, now if you have a scaled down, a smaller version of a data warehouse, if you have fewer subject areas, fewer users, maybe only for a department. Okay, data warehouse you can think of as for the whole college of business. Data mart, it can be for a department. Okay, so data mart is a subset of a data warehouse. It is a scaled down version. It has fewer subject areas and fewer users. Okay, now within that we have dependent data mart and independent data mart. Dependent data mart is another subset that is created directly from a data warehouse, and independent data mart is a small data warehouse designed for a strategic business unit or a department. Okay, it's not created from a bigger data warehouse. Okay, it's a small data warehouse itself for a small unit. Okay, so this is one type of data warehouse, data mart. The other type is called operational data store, ODS, operational data stores. Okay, operational data stores is it consolidates. Okay, operational data stores consolidates data from multiple systems. Okay, and provides a near real-time integrated view of current data. So operational data stores, consolidate data from multiple systems and provides a near real-time integrated view of current data. It stores the information used for running the business on an ongoing basis and for short-term operational decisions. Okay, an ODS is seldom more than a month or 2 old. The third type is called the enterprise data warehouses, which is EDW. An enterprise data warehouse is EDW. It's all encompassing large scale data warehouse that is used across the enterprise for decision making. It requires the integration of data from many sources into a standard format. Okay, so these are the 3 different types of data warehouses: data marts, operational data stores, and enterprise data warehouse. Next, we would talk about the process of data warehousing. Okay, the process of data warehousing. What is data warehousing? Data warehousing is broader in scope. This is the entire process of data extraction, data transformation, and data loading, or the loading of data to the warehouse and access of the data by end users and applications. So what is the process of data warehousing? Once again, data warehousing involves the whole thing, okay, starting from extracting data, then transforming the data, loading the data to the warehouse. Here you can see in this picture, these are the sources from which we are extracting the data, okay. Then we are transforming the data, then we are storing the data in the data warehouse, and then we are accessing the data, okay, through different applications. Accessing the data through different applications. So let's look at the first one. From the data sources, what we do is we import data from internal and external sources. What are our sources? Our sources can be the internal ERP system, okay, internal legacy systems like mainframe, point of sale terminals. Point of sale terminals, you know, like when you are checking out in a retail shop, say Pennies, you are checking out. So that point, when you are checking out, that they are using a point of sale terminals, okay. Other web-based systems or even external data. So these are our data sources. We extract data from there. So after extracting the data, what we do is we clean the data and we organize the data consistently. We clean and we organize the data consistently. Then we load the data into the data warehouse, okay. And you can see here it's an enterprise data warehouse here where we are loading the data. And then from the enterprise data warehouse, we can create data marts as subset of data warehouse. So see, after loading the data here, we created several data marts for each functional unit. So marketing has its own data mart, engineering has its data mart, finance has its data marts, like that. Or what we can do is we can load data directly into the data marts, okay. We can load data directly into the data marts and then we can consolidate the data marts back to the data warehouse. So it operates both ways. We can directly load the data in the data marts and then consolidate it back to the data warehouse, or we can load it in data warehouse and then create the data marts as subset of the data warehouse, okay. And finally, we perform analysis. So you can see all these analyses are being performed, like data mining, reporting, dashboard, okay, custom built applications with all the data that we have. So we are performing analysis. So what are the major components of a data warehousing process? Once again, first is data source, okay. The major components of a data warehousing process is the data source. And data sources, as you know, the data can be sourced from internal operational systems or from external sources, okay. Internal operational systems can be point of sale terminals, can be the legacy systems, can be ERP systems that internally the company has, or it can be from external sources. So data extraction is done. How do I extract data from those sources? Data extraction is done using commercial ETL software. ETL is extraction, transformation and load. Using commercial software, extraction is done, and those commercial software can be you know, Oracle, can be SaaS, okay. There are a lot of ETL software commercially available, so we have to use that software to extract the data. After that, we have data loading. So data is loaded into a staging area where they are transformed and cleaned. Before they are loaded, they are transformed and cleaned, okay, then loaded into the data warehouse. So there is a staging area where they are temporarily stored for cleaning and transforming, and then they are stored into the data warehouse. And then EDW, which is Enterprise Data Warehouse, that's the comprehensive database. that supports decision making. And then you have the metadata. Metadata basically includes rules for organizing data. Okay, it includes rules for organizing data. And then we also have middleware tools. Okay, middleware tools. Example would be like Cold Fusion. And middleware tools, they enable access to the data warehouse from a variety of front-end applications. So these are our front-end applications. Okay, from here we can have access to the data in the data warehouse through that middleware. So this is the API middleware tool. What is that? This is basically example would be Cold Fusion. This is used to allow the front-end applications to draw data from the data warehouse. Okay, so the front-end applications like the OLAP, the dashboard, the mining, the custom build applications, they can access the data from the data warehouse through middleware tools such as Cold Fusion. Okay, this is how the whole thing works. So I have the data sources where the data is like internal to the organization or external. Then through a commercially available ETL software, I extract the data, then I put it in a staging area, I clean it, I transform it, and then load it into the enterprise data warehouse. From the enterprise data warehouse, I also store metadata, which is basically rules for organizing the data. And that data can be put in created subsets like in data marts, and the front-end applications like here custom built applications or OLAP or dashboard or web or data mining, they can access the data from the data marts or the data warehouse with the help of a software called middleware, which enables access to the data warehouse data. Okay, an example of middleware is Cold Fusion. And why do the front-end applications access data from the data warehouse? For performance analysis. Okay, they analyze the data. This is how it works. Okay, then data warehouse can be a two-tier architecture or a three-tier architecture. Okay, in a two-tier architecture, which is simple, the application and the data warehouse are on the same machine. Okay, and in a three-tier architecture, the data warehouse and the application software, they are in different machines. They are in different computers. So you can see three-tier architecture. This is the application server and this is the data warehouse here. But in a two-tier architecture, the application and the database are in the same server. Generally, we prefer a three-tier architecture to a two-tier architecture because three-tier architecture is faster, and when you have the application and the database on the same server, it slows down. Okay, the process becomes slow. Okay, we will talk about integration, extraction, transformation, and loading now. Integration covers three processes, and these three processes are accessing the data, combining different views of the data, and capturing changes to the data. So integration covers three processes: accessing the data, combining different views of the data, and capturing changes to the data. And then we will talk about ETL, which is extraction, transformation, and loading. ETL is the process through which data are loaded into the data warehouse. You know that by now, that ETL is the process through which data are loaded into the data warehouse. Okay, so what is extraction? Extraction is selecting data from one or more sources and reading the selected data. So you can see extraction, we are extracting data from applications, legacy system, internal applications like point of sale terminals, ERP systems, so on and so forth. So extraction involves selecting data from one or more sources and reading the selected data. Transformation means converting data from their original form to whatever form the data warehouse needs. This often involves cleansing of the data to remove as many errors as possible. So transformation is converting data from the original form in which they were collected to whatever form the data warehouse needs. And this involves cleaning of the data to remove as many errors as possible. Okay, so after transformation and cleansing, we load the data. So loading means putting the converted data into the data warehouse. You know that from the data warehouse we can create data marts, or we can directly load the data into data mart and consolidate back into the data warehouse. Okay, so this is extraction, transformation and loading process. And these three together, the integration, also the data integration, which involves the three process of accessing the data, combining the different views of data and capturing changes to the data. Okay, now we will talk about the data warehouse development approaches. Okay, in data warehouse development approaches, we have the Inman model and the Kimball model. Okay, Inman model is called the EDW, Enterprise Data Warehouse approach. It's top down. That means we first have the enterprise data warehouse and then we create data mart as subsets. Okay, so first we have the enterprise data warehouse, we load data there, and then we create data mart as subsets of the data warehouse. In the Kimball model, what we do is we first do the data marts and then consolidate, first load data into the data marts and then consolidate the data back into a data warehouse. Okay, which model is best? It depends. There is no one size fit all strategy. Okay. Now, as I was telling you, I will not talk about dimensional modeling and the star schema today, which is the data warehouse structure. I will need a different day for this. So I will move on. I'll skip that topic and I'll move on to real-time or active data warehousing. Dimensional modeling, star schema and multi-dimensionality, I'm leaving it for the time being. I'll cover it next time. We have an assignment on that, so it's important, but I'll do it on a different day. So I'll move on to real-time data warehousing. Okay, real-time data warehousing or real-time data warehouse is also called active data warehouse, ADW, active data warehouse. Okay. In a real-time data warehouse, data are updated on an ongoing basis as business transactions occur. Example, Continental Airlines, they have a real-time data warehouse, and I insist that I have given you the URL in your syllabus. Here the podcasting of Continental successfully using a real-time data warehouse. Okay, it's given in your syllabus. It's in the Teradata website. Podcasting of Continental success in using a real-time data warehousing and process, and I would like you to hear that. So in a real-time data warehouse, data are updated on an ongoing basis as business transactions occur. There are a lot of benefits of having a real-time data warehouse or business intelligence. It extends benefits down into the lower level of the organization. Not only in the strategic level, a data warehouse can give benefits in the strategic level, but a real-time data warehouse extends that benefit into the lower level, into the tactical level and the operational decision-making levels of the organization. It empowers people who interact with customers and suppliers by providing them with current information. Okay, so customer support people, they will have access to real-time data, so they can make their own decisions. They don't have to be told by middle managers on what to do, because they have access to data real-time. They can make their own decisions. So it empowers employees who deals with customers. So traditional and active data warehousing, traditional data warehouse and active data warehouse environment. Traditional data warehouse, as I was telling you, supports only strategic decisions, helps people in the upper level of the organizations. Okay. But main difference is that active data warehouse helps people in all levels of the organization. So even people who are dealing with customers can have access to real-time data so that they are empowered and they can make their own decision. Okay, so this is the main advantage. Okay, there are some other things that I would be talking about from here. Okay, some of the benefits of the data warehousing. Okay. And especially if you are hosting data, if you are using hosted data warehouses. Okay. Infrastructural investment is not much, then frees up capacity of in-house systems, frees up cash flow. Basically, you can buy the competitive advantage from others. Okay, like if that company is hosting data warehouses, they have the technology, they have the efficiency, they have the connection, faster connections, and you can use it by not having to develop from scratch and using your people for other things that you do best. Okay, so it will allow you to focus on your core competence, sorry. Okay, the only thing I believe that is left that we needed to cover other than dimensional modeling and star schema and multidimensionality is our going over online analytical processing and online transaction processing. Remember that we have done this in chapter 1, but we will do again in chapter 2, because how do I analyze the data in the data warehouse? Okay, remember I extract the data from data sources, then I transform the data, I clean the data, I load it in the data warehouse, then I use a middleware tool to let the front-end applications access this data to perform analysis. Okay, you have to have the process of data warehousing very clear in your mind. So think about the process once again. What I do is I extract the data from data sources, which can be external or internal to the organization. Then using commercially available data extraction software like Oracle, like SAS, we extract the data from the data sources, we put them in a staging area for cleaning them, and then we transform them into the requirements for the data warehouse, and then we load it into the data warehouse. After we load it into the data warehouse, we use a middleware, for example Cold Fusion, to let the applications access that data. After accessing the data, what happens is that the data is analyzed, right? So there are two things that we need to know about data analysis. One is online analytical processing called OLAP, and another is online transaction processing called OLTP. So OLAP is basically data-driven activities performed by end users to query the online system and conduct analysis. We have drill down, we have roll up, we have slicing and dicing, we have data cubes, and OLAP activities, they generate queries, they request ad hoc reports, they conduct statistical analysis, they develop multimedia based applications. And your assignment 4 is on OLAP. Okay, and then online transaction processing is a system that is primarily responsible for capturing and storing data related to day-to-day business functions such as ERP, CRM, customer relationship management, supply chain management, point of sale terminals, etc. OLTP focuses on the efficiency of routine tasks. Okay, and once again, online analytical processing is a system designed to address the need of information extraction by providing effectively and efficiently ad hoc analysis of organizational data. So OLAP is not day-to-day, but OLTP is on day-to-day transactions. So this is the difference between OLAP and OLTP. OLTP is carrying out day-to-day business functions, and OLAP is for decision making on the data stored. Okay, and data source for OLTP is transaction database, but for OLAP it's the data warehouse. Reporting for OLTP is routine, periodic, and reporting for OLAP is multidimensional, ad hoc, broadly focused reports and queries. Resource requirement for OLTP, only relational databases is fine, but for OLAP it has to be multiprocessor, large capability, specialized database. Execution speed is faster for OLTP because it's dealing with day-to-day data, but execution speed for OLAP is slow because it involves resource intensive, complex and large scale queries. Okay, so this is the part of chapter 2 that I wanted to cover today, and so let me go over the study guide and see how much we have covered today. Okay, so we have covered what is a data warehouse, which is pool of data. So I'm basically wrapping up the chapter for you now, which is a pool of data used for decision making. Then we talked about different characteristics of a data warehouse, like subject oriented, like integrated, like non-volatile, like relational, client server, real time, so on. We talked about metadata, which is data about rules about organizing data. We talked about an enterprise data warehouse, which is a all-encompassing large-scale data warehouse that is used for the entire enterprise. We talked about data mart, which is a subset of the data warehouse. We talked about dependent and independent data mart. Then operational data stores. Okay, operational data stores are used for consolidating data from multiple systems and provides a near real-time integrated view of current data. Okay, data warehousing process overview, we have gone over it many times, starting from data sources, then extracting the data, then transforming and loading the data using ETL, commercially available software, then loading it into the data warehouse, keeping the metadata, which is rules for organizing the data, then using a middleware tool for enabling access to the data by front-end applications, and the applications uses either OLTP or OLAP analysis on the data. We talked about data integration, those three processes, and then we talked about extraction, transformation, and loading. We talked about some of the benefits of the data warehouse, star schema and dimensional modeling, primary key, composite key, foreign key. Next time, in-one model, EDW or enterprise data warehouse first, then create the subsets of data marts, and Kimball model is first the data marts, then consolidate them back into the data warehouse. OLAP versus OLTP. OLTP, day-to-day business transactions. OLAP, decision making based on organized data. Then real-time data warehouse, we talked about that, or active data warehouse, which is updated on a real-time basis. And the differences between traditional and real-time. Traditional is used mainly for strategic help in the organization, and real-time data warehouse helps people in all levels in the organization. Even those who deal with customers, they have access to real-time data, and they are empowered.